And most of you will have seen a deck of cards, but a few of you won't. So it's important to know, when we're talking mathematics, what a deck of cards really looks like. You'll see that in any deck of cards there are what we call suits. So we have clubs along here, we have diamonds, we have hearts, and we have spades. Importantly, there are 4 suits. Clubs is one suit, diamonds is another, hearts and spades are all suits. Now we have aces down here, and these aces represent 1, and usually they're a low card, but they can be regarded as a very high card as well. So sometimes their value changes, but don't worry about that. Up here we have picture cards, which are sometimes called court cards, and you can see that we have a jack, queen and king, and all the suits have jack, queen and king. They're usually the highest card values. King is usually the highest, unless we have an ace sometimes as the high card value. Now let's have a look at these particular suits. The first one, called spades, is actually a mistranslation. Well, actually it's not a mistranslation, it's a translation of the word pike. And in medieval times, a pike was like a spear. It was a fighting implement, and we can see that that is kind of like a spear. And I've got a picture of a pike here. That's what a pike looks like. Now hearts make sense, they look like hearts, and diamonds look like diamonds as well. But what about this shape over here? That's called a club. Well, that's also the translation of a French word for clover, and you can see that they both look like clovers. So, as I said before, a deck of cards has 52 cards in it, and that means there are 4 lots of 13. And if I do that, 4 lots of 13, let's just see what that is. 4 times 13 equals 52. But sometimes a deck of cards will come with 2 other cards called jokers. But for mathematics, we're not interested in the jokers, we're just interested in the 52 playing cards. Alright, we have some questions that we need to answer here, and we are told that 1 card is chosen randomly for a standard deck of cards. What is the probability that it is red? Well, let's have a look at this, and what we're going to... Now we can see that A says 1 card is chosen randomly from a standard deck of cards. What is the probability that it's red? Well, here are all the red cards here. We have diamonds and we have hearts. Now you remember there are 13 diamonds and there are 13 hearts. That means there's going to be 13 plus 13 chances out of how many cards are there altogether? 52. So we can write that down as equals, or probability of getting a red card equals 26 out of 52. Now I know some of you are saying, but can't you simplify that? Well, yes we can, so let's have a look at that. We will simplify that. So we're going to say 26 over 52. Oh, comes out to be 1/2. So that's our probability of drawing a red card from a deck of 52. Let's have a look at the next one. Now this time, I'll change the colour here. It says, what's the probability of not being red? Well, see, here are all the not red cards all along here. And there's 13 of those, and there's 13 of those. So the probability of it not being red is going to be the same as what it is if it is going to be red. So there's 13 clubs, and there's 13 spades out of 52. So the probability of not red, now I'm going to put a red here, and instead of putting not red, I'm going to put a line across the top, and that means not red. Probability of not red is equal to 26 out of 52. which is also equal to 1/2. Let's have a look at the next one. Probability that we get a club. Alright, now here are all the clubs up here. How many clubs are there? There's 13 of them. So that's what we're going to do. We're going to write probability of a club equals 13 out of 52. Can we simplify that? Well, let's have a look. 13 out of 52. So we write 13 over 52 and we get our answer 1/4. So the probability of getting a club is 1 in 4, or 1 out of 4, 1/4. And if you have a look at it, it kind of makes sense, doesn't it? Because clubs, hearts and diamonds and spades, clubs is just 1 out of 4 suits. Alright, let's have a look at the next one. Now the next one says not a club. Alright, well how many are not clubs? Well, there's this row here that's not clubs, this row here that's not clubs, so there's 3 lots of 13 that aren't clubs. So probability of club not equals 13 plus 13 plus 13 over 52. Now that's going to come out to be 13 plus 13 is 26. 26 and another 13 comes out to be 39. 39 out of 52. Can we simplify that? Equals 3/4. So the probability is equal to 3 over 4. It's always important to simplify these where we can. Let's have a look at the next one. Alright, well this next one says a 7. Ooh, a little bit trickier. How many 7s do we have? Well, we have, I'm just going to do a different colour here. We'll do this colour here. So we have all these are 7s. All those are 7s. How many 7s are there? There's 4 of them, aren't there? What's the probability of neither a 7 or an 8? Interesting. So we don't want a 7 or an 8. So let's write that down. So we want probability three, 4, 5, 6, 7, 8. 7s and 8s, aren't there? So there's 8 of them altogether. So let's work out, that must mean there are Okay, a red ace. Alright, so let's have a look at these red aces. Well, here's an ace, it's red, and here's an ace, it's red. So the probability of a red ace is pretty straightforward. Probability of a red So we know that altogether there's 13 red cards, there's 13 diamonds and 13 hearts, so that means there's 26 red cards. So minus 2 of the aces means that there's going to be 24. So probability of a red card and not an ace equals 24 out of 52. And then when I simplify that, I get the answer 6 out of 13. Well, Year 7, I hope that this makes it a little bit clearer, and you can go on and do some questions from exercise 5D.